All right, so today we're going to talk about parallel and perpendicular lines and some properties they have. What I would recommend right now that you do is to try this on your own, to pause this video and try this first. I will go through each piece, but this is more meant for you to try this and to review all the formulas, slope, slope-intercept, point slope, which I showed you yesterday as well. So try this, pause it, and then come back to it, and I will go through it with you. So once you graph these, and you have line AB and line CD, and you have found the slope of both of them, which should have been -1/2. You notice, hopefully, that they both have the same slope and that on the graph they look like they are parallel. So the conjecture, and a conjecture is an educated guess based on the information that you have. So the conjecture here, hopefully that you're making, is that they are parallel. And parallel means they have the same slope. Okay? And so parallel lines do have the same slope. They will always have the same slope. Parallel lines have the same slope. Remember that, okay? So if you can find the slope of the lines and it's the same, the two lines are parallel. Okay? I would like you to again pause this and to try this, okay? So find the slope of EF and the slope of GH, and then try and make a conjecture. Hold off on number 3 for right now. Just do number 2. Try and find the slope of EF and the slope of GH. Okay, so using the slope formula, hopefully you figured out that the slope of EF is -1/7 and the slope of GH is -1/6. So although they are not or they're real close, they are not parallel. So they are not parallel because they have different slopes. Okay, so if they don't have the same slope, they are not parallel. Period. End of story. All right. So now we're going to take this other equation that is in standard form and we're going to rewrite it in slope-intercept form, which means we're going to solve for y. So we're going to start by subtracting 6x from both sides. We get -3y equals 9 minus 6x. Divide everything by -3. We're going to get y equals -3 plus 2x, which I'm going to rewrite as y equals 2x minus 3. Okay? So, now, we can identify the slope just from this equation. So the slope of the line would be 2, because that is the number next to our x. And you could identify that here next to the x as well, but it's the coefficient on the x term. But I just like to have it in slope-intercept form where it's mx plus b. So the mx is first and then the b, okay? But if we know the slope is 2, then we know the slope of a parallel line should be the same, and so a parallel line would have a slope of 2 as well. Okay? All right, so we are going to move on, and again, I'm going to ask you to pause and try this on your own. Find the slope of AB, find the slope of CD, graph the two lines, look at it, observe, and make a conjecture or an educated guess based on the information you observe. So, again, find the slopes, graph the lines, and make a conjecture. Okay, so hopefully when you graphed AB and found the slope, it's got a slope of +4/3, and when you graph it, it should look like that on there. And then the slope of CD is -3/4, and that should look like it does on my graph. And again, my graphs are not perfect. And so if you notice, hopefully you notice that these lines, they look like they're perpendicular. They appear perpendicular. Okay, well, I'm going to tell you they are perpendicular. So hopefully the conjecture you made has relation to these slopes up here, these two and their relationship to each other. And that is that they are opposite, which means one's positive and one's negative, reciprocal, which means they're flipped. So one's positive, one's negative, and then they're the flip of each other. And then that means, so opposite reciprocal slopes, that means perpendicular. Okay, so if two lines have opposite reciprocal slopes, they are perpendicular lines. Okay, so if we want to write an equation for a line that goes through a specific point and is perpendicular, the first thing we have to look at is the slope of the original line. So the original line has a slope of -3 or -3/1. And so the slope of a perpendicular line would be the opposite, so it's going to be positive, and the reciprocal, which is 1/3. Okay, and then we want to use that point and use point slope form. So y minus 7 equals 1/3 x minus -3. So that comes into plus. And I'm going to distribute here. Y minus 7 equals 1/3 x plus 1. And then add 7 to both sides, and I get 1/3 x plus 8. And this is the equation of a line with a perpendicular slope, so 1/3, that goes through the point, -3, 7. Okay, and so we've used -3 and 7 in this equation and the 1/3 slope to find that equation of a perpendicular line. Okay, parallel is actually a little easier because I don't need to change the slope. So if I want to do a parallel line, the original slope again is -3, so we're going to leave our parallel slope. So the slope of a parallel line is also going to be -3. And then we'll still use our same point in point slope form. So y minus 7 equals -3 times x minus -3. And so I get y minus 7 equals -3x minus 9. If we add 7 to both sides, we get y equals -3x minus 2. So the equation of a line that is parallel to this line that goes through the point -3, 7 is -3x minus 2. So parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes. Okay, so yesterday we looked at a graph, and on that graph we found the distance from a point to a line, and they were perpendicular because the shortest distance from a point to line is always going to be the perpendicular slope, or the line with a perpendicular slope that goes through that point. But now we're going to do it if we don't have that diagram already drawn, and we don't know those 2 points. We have to find the point that we're going to find the distance for. We're going to really be doing the same thing. We're going to be finding the distance, but we need to figure out that line and the distance, the point that is perpendicular. There's lots of steps here. So this is going to kind of be labor intensive. I'm only going to go through one example with you, but if you look in section 3.5 in the book, there is some more examples as well. And if you would like me to, I can go through more examples, and there will be some on the review for your test that we're going to do tomorrow. And if you're still listening, I would love to know what song is on repeat on your Spotify right now for an extra credit point, or your Pandora or your YouTube music, or what music you're listening to on repeat right now, if you had to pick one song to just keep listening to, because I definitely know there's always one in my head. So one song that you have on repeat, send it to me, and now we're going to do this. So, first thing we're going to do is we're going to find the slope of a line that is perpendicular to the line that we're given. So here's our given line, okay? This line right here has a slope of -1, actually. So the slope here is -1. I want a perpendicular slope. So perpendicular slope is going to be the opposite reciprocal. So this is 1 over 1. So our reciprocal is going to be 1 over 1, or just 1. And it's going to be +1 because that's a -1. Okay? Then the point, we're just going to copy down the point from right here. Okay? So this is the point that we're finding the distance from. We need to figure out the point that we're going to be going to. So we're going to find a perpendicular line that goes through the point 1, 0, that, because that's what's going to intersect our original line of y equals -x plus 3. And we'll figure out then the intersection point, and then we will find the distance. So we're going to write an equation in slope-intercept form, but to do that we're going to use point slope. So y minus 0 equals 1 times x minus 1. So y equals 1x minus 1. So this is our equation of our perpendicular line. Okay. Now we're going to graph the two lines. So our original equation was y equals -x plus 3. So I'm going to start here. And -x tells me to graph this line like this. Okay, because it's down 1 over 1, and the y-intercept is 3. And then our perpendicular line that we just found the equation for is -1, x minus 1. So we start at -1 and go up 1 over 1 from there. Okay. And then we're going to figure out this point of intersection. This is really important. That's what we're trying to find, because our goal is to find the distance from the point 1, 0, right here, this point, to this line right here, this distance, color it darker. And to do that, we need to know this point of intersection, which here is the point 2, 1. So our point of intersection is 2, 1. Our original point is 1, 0, and we're going to use the distance formula now with those 2 points. This is our last step. Okay, so 2 minus 1 squared plus 1 minus 0 squared, so we get the distance is 1 squared plus 1 squared, which is 1 squared is 1, another 1, so it's really the distance is the square root of 2, or approximately 1.4. So this distance, again, right here, so I'm going to erase it, and then I'm going to draw it in again. This spot right here, that's what we were trying to find the distance of, and that is 1.4. I can look at the graph, that makes sense. It looks like it's about 1.4. Okay, now, sorry, that is the end of your notes that we are going to do today. What I would say is that if you get a chance doing another one of these on your own in the homework and you are stuck, please let me know. This is a hard thing to do. On the test, I will give you all the steps. So I will give you step 1 is to do this, step 2 is to do this, step 3 is to do this, step 4 is to do this, because this is a hard process and I'm aware of that. And so again, and then if tomorrow you're in class and you want to go through some more of these, you just let me know and we shall. Okay? Otherwise, go ahead and do your 3.5 assignment and I will see you tomorrow.